Construction projects are among the most complex and ambitious endeavors humans undertake, requiring meticulous planning, engineering expertise, and precise execution. However, history is riddled with examples of construction mistakes that have led to catastrophic failures, financial losses, and even loss of life. These mistakes often stem from poor planning, design flaws, inadequate materials, or oversight in safety protocols. Below are 12 of the biggest construction mistakes in the world, each serving as a cautionary tale for future projects. These examples highlight the critical importance of thorough planning, rigorous testing, and adherence to safety standards in the construction industry. The Leaning Tower of Pisa, one of the world's most famous landmarks, was initially designed to stand tall and straight, but it quickly became apparent that the structure was tilting. Construction of the tower began in 1173, but as the building rose, the ground beneath it began to sink. The soil, a mixture of sand, clay, and shells, was too soft and unstable to support the heavy marble structure. The tilt grew progressively worse, causing serious concerns about the tower's stability. The tilt reached a dangerous point in the late 20th century, prompting extensive restoration efforts. Engineers devised a method of extracting soil from beneath the foundation and adding lead counterweights to slow and eventually halt the tilt. By the early 2000s, the tower's tilt was reduced from 5.5 degrees to a safer 3.99 degrees. Though the error in foundation design was detrimental, the successful restoration efforts have ensured the tower's place as one of the most iconic and enduring structures in the world. The Leaning Tower of Pisa stands today as a testament to both human error and ingenuity, symbolizing how even the smallest design mistakes can have profound impacts. The collapse of the Tacoma Narrows Bridge in 1940 is one of the most famous engineering failures in history, largely because it was caught on film. The bridge, which spanned the Tacoma Narrows Strait in Washington state, was completed in 1940 with a sleek, slender design that was highly susceptible to wind forces. Despite its design seeming to be cutting edge at the time, engineers did not account for the bridge's tendency to sway under certain wind conditions. The bridge's design lacked adequate aerodynamic features to stabilize it against wind gusts, a flaw that became evident when winds of just 40 miles per hour hit the structure on November 7, 1940. As the wind passed through the bridge, it created a phenomenon called aeroelastic flutter, which caused the bridge to oscillate wildly. Within just a few hours, the bridge's oscillations became so severe that the structure collapsed. Fortunately, no one was killed, but the event was a critical learning moment in structural engineering. The collapse led to the development of better methods for calculating wind resistance in bridge design, and modern suspension bridges now incorporate features such as expanded decks, more flexible materials, and advanced aerodynamics to prevent similar disasters. While the Hubble Space Telescope is one of the most successful space missions in history, its early mission was hindered by a critical flaw in its construction. The problem stemmed from the telescope's primary mirror, which was ground incorrectly. The mirror had been manufactured with a slight curvature that was off by just 2.2 microns. A micron is 1/1,000,000th of a meter, a minute difference that nonetheless caused the telescope to produce blurry images. When the Hubble telescope was launched in 1990 and sent images back to Earth, scientists were dismayed to find that they were not as sharp as expected. It was quickly determined that the mirror was flawed, and the images lacked clarity, preventing the telescope from achieving its full potential. Fortunately, a team of astronauts in 1993 conducted a mission to fix the problem, installing a set of corrective lenses known as the COSTAR system. This mission successfully restored Hubble's ability to capture sharp images, and since then, the telescope has provided some of the most spectacular views of distant galaxies, nebulae, and stars. While the initial mistake was costly, Hubble has contributed enormously to our understanding of the universe. The Montreal Olympic Stadium, designed for the 1976 Summer Olympics, became an infamous symbol of budget overruns, delays, and construction failures. Originally planned with a sleek, futuristic design featuring a retractable roof, the stadium's cost skyrocketed from an initial estimate of $200 million to over $1 billion. The retractable roof, a major design feature, was one of the most problematic elements. Engineers underestimated the challenges posed by the roof's complex structure, and during the winter months, heavy snow accumulation caused the roof to collapse in 1999. The collapse of the roof highlighted not only structural flaws but also the lack of foresight in planning for extreme weather conditions. Furthermore, the stadium's construction was plagued by numerous delays, which resulted in the Olympics being held with many parts of the complex unfinished. The high cost of the stadium and the later collapse of its roof became a cautionary tale in the world of architecture and construction. The Montreal Olympic Stadium still stands today, but the experience serves as a reminder that ambitious design must be balanced with sound engineering and realistic budgeting. The 1986 Chernobyl disaster remains one of the worst nuclear accidents in history. While human error played a significant role in the meltdown, the plant's design flaws and poor construction decisions contributed to the scale of the disaster. The Chernobyl nuclear power plant used the RBMK reactor, a design that had critical weaknesses, including an unstable reactor core and a lack of effective containment systems. When a safety test was conducted under dangerous conditions, operators mistakenly disabled key safety systems. A sudden increase in reactor power caused a violent explosion that led to a catastrophic release of radiation. The lack of a proper containment structure meant that radioactive materials spread across vast regions of Europe. More than 30 people died immediately, and the long-term health effects, including cancer and birth defects, impacted thousands more. The Chernobyl disaster exposed the inherent risks of nuclear power when poorly designed reactors and inadequate safety protocols are in place. In the aftermath, the world's nuclear industry re-evaluated its safety standards and sought to design reactors that were more robust and safer to operate. The Fukushima Daiichi nuclear power plant, located in Japan, faced a disaster in 2011 that was exacerbated by both natural and human-made errors. The plant was not designed to withstand a tsunami of the scale that struck the area after a massive earthquake. The earthquake caused the plant's reactors to automatically shut down, but the subsequent tsunami flooded the plant's backup generators, cutting off power to the cooling systems. Without cooling, the reactors began to overheat, leading to a meltdown in 3 of the plant's 6 reactors. Although the plant's design was intended to withstand earthquakes, it was not built with sufficient safeguards against the tsunami. The Fukushima disaster resulted in widespread contamination, and the Japanese government had to evacuate tens of thousands of people from the area. The failure highlighted the need for more robust disaster planning in the design of nuclear power plants, particularly in regions prone to earthquakes and tsunamis. It also sparked an international debate about the future of nuclear energy, with some countries opting to shut down their nuclear plants as a result of the disaster. In 1995, the Sampoong department store in Seoul, South Korea, collapsed, resulting in one of the deadliest building collapses in history, with over 500 people losing their lives. The building had undergone several structural changes during its construction, including the removal of critical support beams to make room for additional floors and escalators. These modifications, which were done without proper consultation with structural engineers, weakened the building's frame. Additionally, the store's owner chose to ignore warnings from engineers who pointed out that the building's support system was inadequate. The building's collapse was a result of these structural flaws, compounded by poor materials and insufficient building inspections. In the aftermath, South Korea enacted stricter building codes and improved inspection practices, and the Sampoong disaster remains a poignant example of the dangers of cutting corners in construction, particularly in commercial buildings. The Sydney Opera House is one of the most iconic buildings in the world, but its construction was far from straightforward. Designed by Danish architect Jørn Utzon, the Opera House's stunning shell-like roof design presented a series of engineering challenges. The initial design required complex structural solutions that engineers were not equipped to handle at the time, causing significant delays and budget overruns. The building was also plagued by disputes between Utzon and the Australian government, with Utzon ultimately resigning from the project before its completion. The Opera House cost over $100 million by the time it was finished in 1973, compared to the original estimate of $7 million. Despite these difficulties, the Sydney Opera House remains a masterpiece of modern architecture, and its design has influenced countless other buildings around the world. However, it stands as a reminder of how even the most brilliant designs can face unforeseen construction challenges. The John Hancock Tower in Boston, completed in 1976, was a bold and modern skyscraper that faced significant issues shortly after its construction. The building's glass facade was designed with large panels that were susceptible to wind forces. Over time, the panels began to detach from the building's frame, creating a dangerous situation for those below. The issue was due to an engineering oversight in the original design, which failed to account for the wind forces acting on the glass panels. To solve the problem, the building underwent a costly renovation to replace the glass and reinforce the facade. Additionally, the tower's design had other flaws, including a need for structural reinforcements. Despite these setbacks, the John Hancock Tower is still one of Boston's most prominent buildings, but it serves as an example of how even the most innovative designs can fall victim to engineering miscalculations. The Vdara Hotel in Las Vegas became notorious for its unintended death ray effect. The hotel's sleek, curved glass facade, designed to reflect sunlight, caused a phenomenon where sunlight was concentrated into a powerful beam. This intense heat beam melted plastic surfaces and damaged cars parked nearby, even causing minor burns to people walking on the streets. The reflective effect also damaged nearby pools and sunbathing areas, creating an uncomfortable and unsafe environment for guests. The building's architects had not foreseen this problem, and the phenomenon was later dubbed the Vdara death ray. After the issue was identified, the hotel added coatings to the glass and took steps to redirect the sunlight to prevent further damage. The Vdara Hotel disaster serves as a cautionary tale of how design aesthetics must consider all potential environmental effects, especially in urban settings with complex reflections. The Millennium Dome, now known as the O2 in London, designed to house the Millennium Experience exhibition, faced multiple challenges during its construction in the late 1990s. Initially conceived as a symbol of the UK's celebration of the new millennium, the project was plagued by poor planning, cost overruns, and delays. The dome's design was bold, featuring a massive circular structure with a fabric roof and a central exhibition space. However, the project faced multiple construction challenges due to the scale and complexity of the design. Originally projected to cost £43 million, the budget quickly ballooned to over £1 billion by the time of completion, with criticism mounting over the increasing expenses. Additionally, the exhibition inside the dome was criticized for lackluster content, poor visitor experience, and ineffective marketing. The dome's controversial nature led to widespread public skepticism, and despite its physical success, the Millennium Dome was deemed a financial and cultural failure. Although the structure was repurposed and transformed into the O2 Arena, the Millennium Dome disaster serves as a reminder of how ambitious, poorly managed projects can result in excessive costs and public backlash. The Vesuvius submarine, a part of the Italian Navy, is one of the most infamous examples of engineering failures in military construction. The submarine was built in the 1970s with innovative features, but it had serious design flaws. One of the primary issues was its structural integrity and lack of proper ballast management. During its trials, the submarine began to experience significant issues with its buoyancy and stability, making it nearly impossible to dive or resurface properly. The ship's design also suffered from inadequate materials and construction techniques that did not account for the stresses of submarine operations, causing it to become prone to leaks and malfunctions. The Vesuvius was quickly deemed unsafe and was eventually decommissioned in the early 1980s after undergoing several failed repairs. This submarine is a notable example of how a combination of poor design, improper material selection, and oversight can lead to catastrophic consequences, particularly in projects involving highly technical and life-threatening equipment like military vessels. These 12 construction mistakes serve as powerful lessons in the importance of thorough planning, rigorous engineering, and adherence to safety standards. They remind us that even the most ambitious projects can fail without proper attention to detail and accountability. Each disaster has contributed to advancements in construction practices, ensuring that future projects are safer and more resilient. By learning from these mistakes, the construction industry can continue to innovate while prioritizing safety and sustainability.